Good morning, everybody. Welcome back. Today is Friday, March the 5th, and this is an addendum, a kind of different video from yesterday. I apologize if the YouTube video did not get posted. So if you have to watch that for the 3As, you can watch that. This one's very, very similar. What we're going to be doing is talking about, first of all, the types of transformations that are for all of our functions. Now, with the base functions, I'm not going to use them. So let's just talk about in ARC what they represent with the letters of the A, the K, the D, and the C. And I know some of you, maybe from yesterday's class, you already know what the F stands for. We'll talk about that. But hopefully it'll make sense. And people here right now live in class, it's okay. So it might be a little discomfort. And this is how I broke it down. Right? A lot of you see a couple of words written 6 times. Not 6 times, 3 times. Vertical, horizontal, vertical, horizontal, vertical, horizontal. But they actually mean something with respect to how they're going to transform. And so, although this is how we traditionally teach it, it's the easier way, but we can actually go from the order how it's written, meaning you do A, then K, then D, and then C. So I'm going to teach you, first of all, the vertical. And basically, this one's the easiest. When you see plus C or minus C, that means it shifts up. C units. And if it's negative, the vertical shift down. C units. Let me give you an example. Again, I don't know what the function is, who cares? But let's just say we wrote f at x plus 5 from someone from the class. Can someone please tell me, what do you think this means of the function? Maybe the function looks something like this. Maybe this is the function f of x. What would that mean to you in English? Adam? F5 units. We take the function and add it 5. And notice how it's written? It's outside. So let's put the green. So, and what would this function be if I were to follow this? Again, this is the function. And I think some of you know that we had some critical point. I'm not, I'm just sketching it. It would shift everything up 5 units, everything up 5 units. And it should be the same. Hopefully I drew pretty. It looks the same, pretty close, but it should be moved up. Analogy, of course, is Mr. Chan. If I went up to the 5th floor, there is no 5th floor. Well, it's the room. 5th floor, the room above us, it'd be 520. A lot of you understand this. In North Toronto, below us, it's 320, and below that, it's 220, and theoretically on the ground floor, it should be 120. All the floors at North Toronto are all aligned the same. And again, if I wanted to shift up, I would still be the same. I'd just be higher up. That's what this is. Just a straightforward shift. Everyone okay with that? This one has a big E. How about horizontal? So some of you are going to see something interesting because it's related to when we taught vertex form. So when you see x minus c, this is actually a horizontal shift right. C. Are you C? I used the wrong letter. It's D. Sorry about that. That's my fault. Sorry, because I'm used to teaching the old way. Horizontal shift right D unit. And if it was x plus D, I think a lot of you know, the horizontal shift left D unit. Notice the horizontal aspect is kind of weird, right? So let me just give you another example, do it above, if that's okay. Let's just say we had a question of a function, and if we input it, and I think some of you are slowly putting in, f at x minus 2. Can someone please tell me in English, what do you think the function is? Again, we don't know what the function is, we care what it is. What direction would this go in this example? Any volunteer? Karen?
Right.
How many units?
2.
Nice. And to make sure you visualize it, let's just say we had a stick person. This is not a function, but a stick person, that's our function. And some of you are still understanding about animation. This is actually a part of animation or music. In music, when they change the key to tone, tone, semitone, or higher up in different major keys. So this is transposition, right? If I take this stick figure, and if I wanted to do this new transformation, it's supposed to be identical. I made the arm a little bit longer. To the right, not to the left, to the right. Everyone see what I'm trying to show you? So this is the original function. It's not a function, but it may move to the right. That's why a lot of you actually understand in maybe video games or animations or movies, the CGI, if it's not immersive, it's disjointed or it's not done very well, it's very jarring, right? It's very jarring. But this is what we're doing. Any questions so far of the translation? These are all the shifts. These ones tend to be easiest. The C and the D. Any question with that? And again, if you're watching at home, feel free to pause the video and maybe zoom in. Any questions so far? From the class. So now we get to stretches and compressions. And slowly some of you are realizing, this is not so bad. The stretches and compressions for A, especially for vertical, are not that terrifying. So when A is greater than 1, the transformation is called a vertical stretch by a factor of A. I like giving an example for this one. And if you're watching at home, again, North Toronto, they're still back at the old system of doing the old period way back in grade 9. Back to this. So let me just give you an example for this. Let's just say we have this function. And I'm trying to go as slow as possible so you can see it. And let's be specific. Let's just say we had f at x was equal to x squared. So this really means a quadratic. Everyone agree? So if we take that quadratic, visualize it, and hopefully everyone can see that at home. Maybe you might have to zoom in. Maybe I'll move it a little bit closer so people can see it. They can focus. It's a little bit better now. What should the new object be? This is the function here. Any volunteer? What should happen to this quadratic? Any volunteer from the class? Well, it should be vertically stretched, right? It should be very, very skinny. So it's going to be this one, right? Everyone see that? So you take it and it's actually being stretched. That's what we call vertical stretch, going upwards. Everyone see that? How about when A is in between 1 and 0? Well, this is what's called a vertical compression by a factor of A. Now, some students, when they see this, you've written A twice here, and it doesn't really mean anything. So, a lot of students find this difficult, but the vertical stretch or compression, it's directly related. Directly. So, for example, if it was a half, if I changed it to a half, it'd be vertically compressed and it gets nice and squashed, right? So, you take my face, let's say for the vertical compression, you squash my face like that. My face gets wider. So it's directly related. Everyone okay with this? Any questions? The hard one a lot of you realize is, and it's new, is a horizontal stretch or compression. And this is why we teach this not in grade 10, but in grade 11, because a lot of you have a bit more resiliency to understand. A lot of you actually understand what I'm trying to do with the A, D, and C. It's analogous to what you were taught in grade 10 of the vertex form, A, H, and K. Just to share with you, and again, I know the variables are a little confusing, so I don't know why we don't just keep it uniform. That's why I can teach A, P, and Q, because it's a little bit easier. So the new one is actually horizontal, and it relates to K. And hopefully everyone's paying attention. You might want to look first before you start copying the note. This one's a little weird. When K is greater than 1, it's not directly related to the effects. Watch carefully what this means. When K is greater than 1 in the function notation when we write it, it really means it's a horizontal compression by a factor of 1 over K. And some students need to see the example. That's why I'm trying to leave this one on the chalkboard. Because notice the A is outside of the function. For K, let me show you my example. Notice where I put the 2. It's not in front, it's actually inside the brackets. Can someone from the class maybe tell me what kind of compression is this? How would you say this is something? Any volunteer want to try? Someone have to do the math? Anybody from the class? So the way you would say the type of transformation in this example, it's a horizontal compression by a factor of 1 over 2, or half. Notice I didn't say directly, I didn't say 2. This is a half. So K values are actually inversely related. And let's just pause here for a second. A lot of students find this hard. For example, if you stay up late for class, stay up late, like it's late at night, notice what happens to your marks usually? They go down. They don't go up usually. Depending, of course, what you're doing, staying up late for, right? If you stay up late, partying, whatever, hanging out with friends, whatever, playing video games and not studying, you stay up late, what happens to your marks? Tend to go down. They're inversely related. They don't both go up, right? I'm partying every day, and my marks are getting even better. Look at that. No, it doesn't work that way. So it's inversely related. Anyways, that's the analogy. Let's keep on going. When K is in between 1 and 0, it's a horizontal stretch by a factor of 1 over K. So notice 1 over K, that's what it means, inversely. Let me give you an example here. Let's just say it was f at 0.2 x. Did someone from the class tell me? How would you describe that f at 0.2? Again, conclude this is a K value, 0.2. Can someone actually tell me? What does that mean in English to you? Adam?
Horizontally stretched by 1 over 0.2.
Yeah, do you know what 1 over 0.2 is actually? It's actually, can someone help me out? It is a stretch.
Is that 5?
It is 5. So it's going to get wider by a factor of 5. Notice, even though K is 0.2, it gets stretched by a factor of 5. That's why some students find this weird. K is not directly related. One more time. When A is greater than 1, it's vertically stretched. When A is in between 1 and 0, it gets vertically compressed. So it's a smaller number, but it's directly related, directly. K is a little bit different. When K is greater than 1, it's actually a compression, horizontally. So I'm trying to point. When K is in between 0 and 1, it's a stretch, it gets wider, wider. So some of you are kind of confused, and that's okay. That's why a lot of you realize for the quadratics, we don't introduce horizontal aspects because, and that's why I think a lot of you understand this, the vertical compression is the same as a horizontal stretch, and vice versa. A vertical stretch is the same as a horizontal compression. And that's why we wait till grade 11 to kind of introduce this. There's a couple things I've actually cheated just a little bit, because your handout also does it. Does anyone actually see anything interesting about the forms now? A lot of you see the A, K, B, and C. Anyone see anything interesting, especially for this one? Anyone see anything interesting with this? And this is called the general function notation. And if you don't get this today, it's okay, but you'll see this over and over again. But does anyone actually see anything from the class? Something that maybe I've kind of misled you just a little bit? Anyone see it? Anyone from the class? Notice how it's written? I think a lot of you now understand F stands for the function. So that's why F isn't a number here. The C, the D, the A, and the K, those represent numbers or values. Anyone see anything interesting with the format of the notation? The format of notation actually looks like this. A, F, at, notice the square brackets. K, and notice this bracket. X minus D, see this part? Oops, no. See, it's someone didn't catch that. This X has to be by itself. In other words, what I should have done in these examples here, I should have actually written it like this. it just gets a little messy. And see what it says? So technically it should look like that. Everyone see that? Let's pause the video here and let's answer some questions.